Guys, this is session number 2 on continuity and differentiability. Okay, so let's go to the exercise 7a, which we were solving, right? And we are not following the textbook order, but then we'll cover up the easier problems first. That's what we had discussed in the previous session. Question number 13, sub question B. Okay, so f of x is equal to 1 plus modulus of x upon x. Okay, for x not equal to 0, and f of x is equal to 1 when x is equal to 0. So if you read the question, they have given something like this: f of 0 equal to 1. So this is the value of x. Okay, x is equal to 0, f of x is 1. So you need to know this. And we need to discuss the continuity at f of x equal to at x equal to 0. Okay, so we have to check whether the function is continuous or not at x equal to 0. It's given in the problem very clearly, right? So we'll start with the left hand side. Limit LHL, limit x approaching 0 minus 0 minus f of x, and f of x will be 1 plus modulus of x upon x. Okay, now the thing is, this is true for both x greater than 0, x lesser than 0. It is true for both. So left hand side limit is this. So let x is equal to 0 minus h. As x approaches 0, h will also approach 0. So this all things are should be pretty clear by this time, I guess. 1 plus modulus of 0 minus h upon 0 minus h, limit h approaching 0, 1 plus modulus of minus h upon minus h, equal to limit h approaching 0, 1 plus modulus of h is h. Modulus of h is h. Negative becomes positive, and minus h will remain as it is. So this and this is gone. So we are left with 1. So 1 plus 1 upon minus 1. Now, what is 1 upon minus 1? 1 upon minus 1 is minus 1. So 1 minus 1. So plus into this minus will become minus. So that is equal to 0. So LHL is equal to 0. Just remember this. Okay. Now, ideally, we need not solve RHL for this particular problem. I'll tell you why. See, LHL should be equal to RHL, should be equal to f of x equal to 0. Right. Now, this is 0 that we have got, and f of x is equal to 1. So both are not equal. Okay. But then in exam, to be on the safer side, you also show RHL to the paper corrector so that you don't miss out on any marks if at all they want to cut any marks for not showing RHL. So let's avoid that situation. Okay, so RHL, I leave it up to you. In RHL, the only thing is you have to use 0 plus h over here. So this will be 0 plus h. Check what is the RHL value. You can do it on your own. Fine. Let's go to question number 14. 1, 4. Same exercise. Now this time we don't have to prove that it is continuous. The function is continuous. It is given continuous. Are you understanding this fact? So we don't have to prove whether it is continuous at x equal to 2 or not. They have given it is continuous. So given f of x is continuous at x equal to 2. So this statement is given. Now f of x is split into three parts. Okay. 2x minus 1 when x is less than 2. A when x is equal to 2. And x plus 1 when x is greater than 2. So LHL equal to RHL equal to f of x equal to 2. So this is a true thing. We don't have to prove that all three are equal. It is already equal. Okay. So now LHL, okay, limit x approaching 2 minus f of x. Okay. So 2 minus indicates x is less than 2. X is less than 2 is 2x minus 1. X is less than 2 is 2x minus 1. Okay. So let x is equal to 2 minus h. As x approaches 2, h will approach 0. Okay. As x becomes 2 over here, 2 will get cancelled, h will be 0. Right. So this will be limit h approaching 0. Okay. 2 into 2 minus h. Wherever there is x, put 2 minus h minus 1. Limit h approaching 0. There is no denominator, so we can no need to simplify this further. If there is no denominator, you can just put the value of h as 0. So 2 into 2, 4 minus 1, that is 3. Okay. So now try and understand one thing. This problem also we need not solve LHL, RHL both. LHL we got it as 3 and f of x equal to 2 is a. So what is the answer? The answer is 3. The value of a is 3. Okay. I hope you got the point. Let's go to the next problem, that is question number 15. Okay. Now they have given find out the relation between a and b such that f of x is equal to ax plus 1. This is true when x is less than or equal to 3, and f of x is equal to bx plus 3 when x is greater than 3. Now given they have given f of x is continuous at x equal to 3. They have given this. We don't have to prove. Okay, so LHL at x equal to 3 should be equal to RHL at x equal to 3 is equal to f of x equal to 3. Fine. Equation number 1. So LHL, limit x approaching 3 minus. 3 minus is just a second. I think I erased that. Yeah. 3 minus is x less than 3. So ax plus 1. Let x is equal to 3 minus h. As x approaches 3, h will approach 0. Okay. Limit h approaching 0, a into 3 minus h plus 1. No denominator, just put the value of h as 0. So this is equal to 3a plus 1. This is the LHL. I'll start with the RHL. Limit x approaching 3 plus. 3 plus means x is greater than 3. Okay, so it is bx plus 3. Let x is equal to 3 plus h. As x approaches 3, h will approach 0. So this is limit h approaching 0, b into 3 plus h plus 3, b into 3 plus 0. No denominator, no need to simplify this. Okay, so this is 3b plus 3. So this is the RHL. Okay, now I think from 1, okay, we'll try to just equate this to. This is not really required. If you solve this, it's the same function ax plus 1. Okay, x equal to 3. So LHL equal to RHL. So LHL is 3a plus 1. 3a plus 1 equal to 3b plus 2. Okay, so 3a plus 3b, this will give me 3a minus 3b, sorry, equal to 1. Or a minus b is equal to 1 upon 3. That way also you can write. I hope you all understood this. Okay, 3b plus 3, this is, sorry. Yeah. So 3a minus 3b is equal to 2. That's your answer. Fine. Then let us go to the next problem. That is question number 17. Okay. Find the value of k so that the function f defined by f of x is equal to is continuous at x is equal to pi. So f of x is equal to kx plus 1. F of x is equal to cos x. X is less than or equal to pi. X is greater than pi. Okay. So this is the function given. We need to find out the value of k. And it is also mentioned that f of x is continuous at x equal to pi. So LHL equal to RHL, f of x equal to pi. Okay, this is the known thing. We'll start with LHL. limit x approaching pi minus. Pi minus is x less than pi. Less than pi is this. It is clubbed with equal to also. So kx plus 1. Okay. Let x is equal to pi minus h. As x approaches pi, h will approach 0. So limit h approaching 0, k into pi minus h plus 1. Okay. Replace x with pi minus h. K into pi minus 0 plus 1. K pi plus 1. Okay. So LHL part we have solved. RHL. Limit x approaching pi plus. So pi plus is x greater than pi. X greater than pi is this function cos x. Okay. So now see guys, let x is equal to pi plus h. As x approaches pi, h will approach 0. So this will be limit h approaching 0 cos pi plus h. Now pi is over here. Pi is 180 degrees. Everybody is aware of that. Plus indicates anti-clockwise direction. So in this quadrant, your cos is negative. Cos is negative. Okay. And then x-axis. Pi is on the x-axis. Cos remains cos. Cos h. Right? Okay. So this was taught to you in grade 11. So minus cos 0. Cos 0 is 1. So this is minus 1. So see now from 1 LHL equal to RHL. So LHL is equal to k pi plus 1 equal to minus 1. So k is equal to, you can solve from this, minus 2 by pi. Okay. I hope you're understanding this. Okay, let's go to question number 18 now. F of x is equal to root of 1 plus kx minus root of 1 minus kx upon x. This is true for x lying between minus 1 and 0. And f of x is equal to 2x plus 1 upon 2x minus 1. So this is true for 0 less than or equal to x less than 1. Okay. So this is the question given, and f of x is continuous at x equal to 0. So this is given. Okay. So LHL equal to RHL at x equal to 0 is equal to f of x equal to 0. Fine. So this is equation number 1. We'll start with the left hand side limit. Limit x approaching 0 minus. 0 minus is x less than 0. Root of 1 plus kx minus root of 1 minus kx upon x. Okay. Yeah. So what we'll do is we'll just let x is equal to 0 minus h. As x approaches 0, h also approaches 0. So limit h approaching 0, 1 plus k into 0 minus h minus 1 minus k into 0 plus h upon 0 minus h. So limit h approaching 0, 1 minus kh minus 0 minus, no, sorry. So this is minus over here. This will be 1 plus kh upon minus h. So now we are going to rationalize this. Root minus root in the numerator or denominator or both in limits. We rationalize. So the rational of the numerator will take conjugate 1 minus kh plus root of 1 plus kh, root of 1 minus kh, root of 1 plus kh. So this is a minus b, a plus b. So a minus b into a plus b is a square minus b square. Limit h approaching 0, a square, this is h over here, minus b square upon minus h, 1 minus kh plus root of 1 plus kh. I hope I have copied this correctly. 1 second. Okay, so a square minus b square. Limit h approaching 0, 1 minus kh minus 1 plus kh, 1 minus kh, 1 plus kh. So this 1 and 1 is gone. Minus kh, and this also is minus kh, minus 2 kh, because plus into minus is minus, minus 2 kh. Okay, minus 2 kh upon minus h, root of 1 minus kh plus root of 1 plus k. So h gone, minus minus gone. Now you can put the value of h as 0. So this will be root 1. K into 0 is 0 plus 1, and 1 minus 0 and 1 plus 0 is 1. Root of 1 plus root of 1. So this when these two will get cancelled. So LHL ka final answer. Okay, now we'll start with I. Don't keep any step, even if I'm skipping, I don't do that. X 0 plus is x greater than 0. See, this is greater than 0. 2x plus 1 upon 2x minus 1. I think I just got disconnected. So RHL x approaching 0 plus 2x plus 1 upon 2x minus 1. So let x is equal to 0 plus h. As x is approaching 0, h will also approach 0. Limit x approaches 0, that's what I've written over here. Okay? 2 into 0. Replace x with 0 plus h. Okay, so 2h plus 1. You have to simplify because denominator is there upon h minus 1. Now further we cannot just simplify. So it is 1 upon minus 1, which is minus 1. Now see, LHL we got as k, RHS is minus 1. The value of k is minus 1. Okay, LHL equal to RHL. That was the condition given, right? Fine. So 2y plus 1 upon, oh sorry, this is x minus 1. And this one is x minus, excuse me. So minus 0 So I'm just solving this once again. I think there was some connectivity issue. RHL I'm solving. Limit x approaching 0 plus. So 2x plus 1 upon x minus 1. This was the case. Okay. And yeah. So let x is equal to 0 plus h. As x approaches 0, h will also approach 0. Right? H will also approach 0. So limit h approaching 0. 2 into 0 plus h plus 1. X, x is 0 plus h. 0 plus h minus 1. So 2h plus 1 upon h minus 1. Limit is h approaching 0. So 2 into 0 plus 1 upon 0 minus 1. 1 upon minus 1 is minus 1. Now LHL, we had got it as k. So from 1, LHL is k, RHL is minus 1. So k is minus 1. I checked this multiple times, RHL, but then I think the textbook answer is a bit incorrect over here. Fine. So that was your question number 18. Let's go to question number 19. Question number 19. Yeah. So the question is f of x is continuous at x equal to 0. F of x is continuous at x equal to 0, and f of x is equal to 1 minus cos 2x upon 2x square, x not equal to 0. F of x is equal to k, x equal to 0. Okay. Now see guys, since it is continuous at x equal to 0 is LHL, therefore LHL equal to RHL equal to f of x equal to 0. Okay. Now see, x not equal to 0 is for both x less than or greater than. So and okay, while proving we can we have to solve both, but then you know while finding out a certain value when it is continuous, solve any one and equate to x equal to 0. X equal to 0 is k, so this part is k. Okay. Now we'll start with RHL because you can also start with LHL, no problem. So 0 plus, I'm avoiding that minus sign. 1 minus cos 2x upon 2x square. Let x is equal to 0 plus h. As x approaches 0, h will also approach 0. Okay. Limit h approaching 0. 1 minus cos 2 into 0 plus h. 2 into 0 plus h the whole square. So limit h approaching 0. 1 minus cos 2h upon 2h square. 1 minus cos 2h, half angle formula. Limit 2 sin square h upon 2h square. So 2 is getting cancelled. 2 is getting cancelled. 1 minus cos 2h is 2 sin square h. 2 got cancelled. So limit h approaching 0. Sin h upon h the whole square. Now sin h upon h approaching 0 is 1. I hope you know the formula. So this is equal to your RHL. Now from 1, as I said, no need to calculate LHL for this problem because it is encapsulated in x not equal to 0. Both are a part of the same thing. So RHL we have got 1 and x equal to 0 is k. So 1 is equal to k. Okay. Let's go to question number 20. 20. Okay. Let's go to question number 20. Now they have given prove that the function f of x is equal to. Now this time it is a proof. Huh? So let's be a bit cautious while solving. X not equal to 0 and f of x is equal to k, it is when x equal to 0. Remains discontinuous. It is never going to be continuous. Okay, is what they are trying to tell. So LHL equal to RHL equal to f of x equal to 0. This we need to prove this time. Now this is already k. Okay, so we'll calculate LHL, RHL. You can calculate any one because this indicates both lesser than, greater than. This time I'll go ahead with RHL also, RHL as well, because I'm avoiding the minus sign. X approaching 0 plus. Okay, the function remains same for LHL, RHL. When the function remains same for LHL, RHL, no need to solve it separately. But then since it is a proof, okay, we'll solve it separately since it is a proof. Okay, so I started with RHL, so let me just proceed with RHL. X upon modulus of x plus 2x square. Let x is equal to 0 plus h. As x approaches 0, h will also approach 0. H approaches 0, 0 plus h, 0 plus h, 2 into 0 plus h the whole square. Limit h approaching 0, 0 plus h is h, modulus of h, 2h square. Okay, so modulus of h will be h in the next step. Limit h approaching 0, h upon h plus 2h square. Limit h approaching 0, down you take h common, so it will be 1 plus 2h. Okay, so this is gone, we are left with 1. Let me just check whether I'm writing this correctly or not. X upon modulus of x plus 2x square. Okay, x upon modulus of x plus 2x square, 0 plus h. Okay, so 1 upon 1 plus 2 into 0. So 1 upon 1, which is 1. So we got LHL, RHL. We'll start LHL. Limit x approaching 0 minus f of x. F of x remains the same. The function is same for both LHL as well as RHL. X is not equal to 0. Oh, sorry. One second. Let x is equal to 0 minus h. As x approaches 0, h will also approach 0. Limit 0 minus h. So modulus of 0 minus h plus 2 into 0 minus h the whole square. Limit h approaching 0 minus h upon modulus of minus h plus 2 into minus h the whole square is h square. Modulus of minus h is h. Okay. So minus h, just a second, sorry. Minus h upon h plus 2h square. Take h common in the denominator. So this is minus 1. Now the thing is, LHL is not equal to RH. So let the value of k be anything. In the problem, let the value of k be anything. Okay, but then these two are not equal at all. So LHL not equal to RHL. So whatever is the value of k, the function is going to remain discontinuous at x equal to 0. Fine. Okay, so this is what the concept is. Yeah. Let's go to the next problem. We'll understand what is removable discontinuity. So in the exercise, there are three problems. We'll just do that 21, 22, and 23. And then this session will get over. F of x is equal to 2x square minus 8 upon x minus 2. It is undefined at x equal to 2. So when x equal to 2, this function is undefined. When x is equal to 2, this function is not defined. Because see, denominator 2 minus 2 is 0. Na? So x should not be equal to 2. Okay. They are asking what value should be assigned to f of 2 so that the function is continuous at x equal to? So at x equal to 2, what is the value of the function there? Okay, what is the value of the function? Such that the function will be continuous. Okay, so if f of x, understand the steps, is continuous at x equal to 2, LHL should be equal to RHL should be equal to f of x equal to 2, right? Now, x not equal to 2 has both x greater than 2, x lesser than 2. So now this time we are not proving it is continuous. So you solve any one, na? LHL or RHL. So I'll take LHL, LHL, limit x approaching 2 minus. Okay. What is the function? The function is 2x square minus 8 upon x minus 2. Let x is equal to 2 minus h. As x approaches 2, h will approach 0. So limit h approaching 0, 2 minus h the whole square minus 8, 2 minus h minus 2. Okay. Limit h approaching 0, 4 minus 4h plus h square. I'm expanding this a minus b the whole square minus 8 upon 2 minus 8 upon 2. 2 minus h minus 2. 2 2 gone. So this will be 8 minus 8h plus 2h square. 8 minus 8h plus 2h square minus 8. Upon down it is minus h. I'll show you the previous slide. Okay. So this 8 and this 8 is gone. In the numerator, if we take minus h common, okay, so minus 8 minus 2h will be there within the bracket. I'm taking minus h common. Okay. So minus h is gone. Minus 8 minus 2 into 0. The answer is minus 8. Okay. So now see guys, we got the value of this thing as minus 8. Okay. That is question number 21. Just a second. Just checking few things over here. 4 minus 4h plus x square minus 8. 8 minus 8h plus 2x square. Okay. We got the value as minus 8. Fine. One second. 2x square minus 8 upon x minus 2. 2 minus h. 2 minus h. I think something is incorrect. So just giving a relook. 8 minus 8h plus 2x square minus 8. I got the answer as minus 8, but then somehow the textbook is getting 8. I don't know how they're getting 8. Okay. So I think this is minus 8. LHL is equal to minus 8. Now since the function is continuous at x equal to 2, so this both are equal. LHL is equal to minus 8. Okay. And this value was a question mark. So which value is assigned to x is equal to 2? X is equal to 2 is minus 8. Okay. Guys, I just figured out one small error. When I take minus h common, so this will be plus 8, okay? So excuse me for this. So this is 8, right? And then see this, this is also plus 8. So question mark is equal to 8. So f of x equal to 2 is equal to 8. Fine. Okay. So now let's go to the next problem. That is question number 22 is 21 is over. So let's go to question number 22. Okay. Yeah. In question number 22, f of x is equal to x square minus 1 upon x cube minus 1. And then it is undefined at x equal to 1. So when x is equal to 1, this function is not defined. So this is x should not be equal to 1 so that the function is defined, opposite of it. So f of x should be what when x equal to 1? So they're asking what is the value of f of 1? So when x is equal to 1, what is the value of the function is what they are asking. Okay. So if f of x is continuous at x equal to 1, okay, LHL equal to RHL equal to f of x equal to 1. Equation number 1. Now this indicates both greater than and less than, right? So you can solve any one LHL, RHL since it is not a proof. So I'll go ahead with LHL. LHL is, go ahead with RHL because I don't want to involve that minus sign. RHL is equal to limit x approaching 1 plus f of x square minus 1 upon x cube minus 1. Okay. So let x is equal to 1 plus h. As x approaches 1 this time, h will approach 0. So limit h approaching 0. Okay. 1 plus h the whole square minus 1 upon 1 plus h the whole cube minus 1. So 1 plus h the whole square, a plus b the whole square, a square plus 2ab plus b square minus 1 and a plus b the whole cube, a cube plus 3a square b plus 3ab square plus b cube. Okay. The ones are getting cancelled. So we'll take common h over here. Okay. Just write it on this page itself so that there is no error. H and down also will take h common. So this will be 2 plus h and down it will be 3 plus 3h plus h square. Okay. So h gone. Now you can put the value of h as 0 over here. You can put the value of h as 0. So this terms will be 0. So this is going to be 2 upon 3. Okay. So the LHL we solved, we got it as 2 by 3. And as I said you in the beginning, no need to solve RHL in this problem. So 2 by 3. Now 2 by 3 is equal to f of x equal to 1. So the value assigned to f of x, the value assigned to x equal to 1 is 2 by 3. Fine. Let's go to the last problem of this particular session. That is question number 23. Okay. F of x is equal to 3x plus 2 sin x upon x. This is when this is continuous. Okay. At x equal to 0. Okay. And this is x not equal to 0. See, if x is equal to 0, anything upon 0 is not defined. So x is not equal to 0 for x. So what the function should take up as a value when x is equal to 0 is what is asked. And given that f of x is continuous at x equal to 0. So limit, the left hand side limit is equal to right hand side limit is equal to f of x equal to 0. Equation number 1. To avoid the negative sign, I'll go ahead with RHS. It's not a proof, so that we have to do both. So RHL is equal to limit x approaching 0 plus. Okay, the function is same for both. Okay. So now see, let x is equal to 0 plus h. As x approaches 0, h will also approach 0. limit h approaching 0, 3 into 0 plus h, 2 into sine 0 plus h upon 0 plus h. Limit h approaching 0, 3h plus 2 sine h upon h. Now we're going to split this 3h upon h and 2 sine h upon h. So limit h approaching 0, 3h upon h plus 2 sine h upon h. Now h cancel, and this sine h upon h approaching 0 is 1. So 3 plus 2, that is equal to 5. So we got the value of RHL. And since not being a proof, I'm not calculating LHL. Okay. I think I misread the problem. They're asking whether it is continuous at x equal to 0. So sorry for that. Uh, Extremely sorry. So it's not given. We have to prove. So we'll calculate both LHL also now this time. Limit x approaching 0 minus f of x. So 3x plus 2 sine x upon x. Okay. So let x is equal to 0 minus h. As x approaches 0, h will also approach 0. So limit h approaches 0, 3 into 0 minus h plus 2 into 0 minus h upon 0 minus h. So limit h approaching 0 minus 3h. See, sine of minus h is minus sine h. So this is going to be minus 2 sine h. Sine of minus h is minus sine h. Minus into plus 2 is minus. Okay, now you can take minus sign common. 3h plus 2 sine h upon minus h. Okay. So this is going to be 3h upon h, and the minus sign will get cancelled. Limit h approaching 0, 3h upon h plus 2 sin h upon h got cancelled. Okay, and then sin h upon h is 1. So this is also equal to 5, right? So I think this function is pretty much continuous. Okay, because both LHL and RHL is equal, are equal. So both are equal, both are 5, but then this value is not given to us. This value is not given to us. So I think somewhat I feel that the problem is a bit incomplete. They should have given this value. Okay, so a bit of ambiguity is there in this particular problem. Fine. Otherwise, the function is continuous. But then we need to know the value of f of x equal to 0. The value of f of x when x is equal to 0. Okay. Chalo, thank you.